All right, we have Lab1 Analysis. So to start the analysis, first, we've collected all of our data, we've downloaded that data, we put it into a folder on our hard drive, and now we can navigate to that folder, and we need to include all of that data so that MATLAB can see it. Remember how we do that is we go to our folder that contains all of our data. We right click it and we go add to path. Right now that it's black, it's highlighted instead of grayed out like these folders. Now we can tell that MATLAB definitely has some access to these files. So we can go ahead and load this information just by either double clicking it. We can just go double click and you can see that it's going to say load this function. There's a function that takes in a string, and that string is basically a location on your computer, right? In C, right? So if we load that data like this, or by double clicking it, or we load it just by typing load and then apostrophe, we can right click and rename, highlight the name, copy paste that, right? So either one of these methods is going to work. So this load function is going to either take in an absolute position of the file on your hard drive or a relative position that it can see, like any kind of folder that's black, bold and black. MATLAB can see it, so it'll find it. If you couldn't see it, say like we had another one called 1, it's going to give you an error in load, right? It's going to look like this. And that means that MATLAB doesn't have access to this file or you haven't named it correctly. So let's go clear the workspace or command window. And let's look at the workspace here. We have 4 variables that we loaded in from our data: acceleration, angular velocity, orientation, and position. So to extract this data, say the XYZ acceleration, we first have to go and inspect it. So we can double click on that. We can see that this is a table of a bunch of variables, just like you would see in Excel. So in this case, you have a timestamp, which is basically a recording of exactly the time down to the millisecond. We have X acceleration, Y, and Z acceleration, right? So to extract anything here, we type in the variable name that we want to consider here, acceleration. You have to make sure the capitalization is there, right? And then the column name that you want to extract, right? In this case, it would be acceleration dot X, right? And then we want to be able to store that into a variable. So you go right, AX equals acceleration.x. Okay, so now we have a new MATLAB array, has a type double, and this is just a 1D vector that goes all the way to like, it looks like 5,000 data points, kind of crazy. So if we want to visualize this, we just go and plot. We can plot AX. Now we can see some of our data over time, right? And you can see there's some periodicity to this data, and what we want to do in this analysis is extract the period of that signal, right? We want to extract one period for all periods and then overlay them together, right? Just like it says on the homework or the lab work. So essentially we want to find the locations of all these peaks, right? We want to find the distance from peak to peak. And if that distance is fairly regular, we are able to just crop out each individual section and then overlay them, okay? So Now that we have our kind of our goal in mind, let's go ahead and make a script. So I'm going to go into our current folder and I'm going to go right click new script. And let's name something, let's say acceleration data analysis. All right, and it's going to open up here. And we want to basically do everything we just did in the command window. We want to load the data, we want to extract the acceleration information, and then we want to plot it. And what's nice about this is that we're able to start fresh every single time. So the first thing we're going to do is write clear CLC. And then we want to talk about what do we want to do in this script, right? The first thing we want to do is load that data. The next thing we want to go ahead and do is extract. Extract each data vector and plot it. Okay, so one nice thing about MATLAB is we can do these double percent signs to do what's called a section. So I've named a section. You can see that the difference between that section header and just a regular comment is that this is bold. These section headers are bold, and we're going to see that how we're going to use these sections in a second. But first thing we do, we make whatever we want to extract or whatever we want to do in the script. We go ahead and outline all of that, right? Then we go ahead and take the things that we already know how to do from our quick analysis in the command window, and we just copy and paste it. So I know that this works. We just did it. So we're just going to say load this data set, right? And that data set corresponds to a name that is make sure that MATLAB can see it in this folder, right? Then we're going to extract the data vectors. So we know from our previous experience in the command window that we have a variable called acceleration that comes out of this thing. So all we got to do is copy that, paste it, and let's get the Y acceleration data and the Z. We can just write that like this. So we've extracted the data that we want, and that's our acceleration in XYZ. We should also extract the time. So T is equal to acceleration dot timetable. So if we run this so far, do we get any errors? Yeah, we got an error. Okay, what is variable name timetable? Let's see. Let's open this up. Man, I call it timetable. It's actually called timestamp. All right. So let's rename this thing timestamp. Okay, cool. Everything worked. So if we want to plot it with the timestamp, we can do plot again. And this time, because we made timestamp a vector, we can put that in first. That's kind of our independent variable or X variable, right? Then we can look at AX again, acceleration in the X direction. Now if we run all of this again, we can see that it goes here, it clears all the data. It clears the command window, it loads the data again, and extracts the data into these column vectors, and then it goes ahead and plots it. All right, So now we want to make sure that we're taking into account any type of rotation the phone had initially, all these things, right? So we can't just use one of our acceleration coordinates or our directions. We have to think about all these directions at once. And how we're going to do that is talk about the magnitude. Right? Instead of these acceleration vectors, let's just look at the magnitude and see if we can plot out some better data from that, because now we don't have to consider the orientation of the phone at any given time. We can just talk about, did this phone move? How fast did this phone move? Not how fast did this phone move in a direction, right? So let's say this variable a mag is going to be equal to the square root of ax dot squared plus ay dot squared plus az dot squared. Right? So this says, how do you extract the vector magnitude? Right? You take the square root of the sum of the squares of the vector components. So this is going to give me a column vector a mag, the same size as ax, ay, az, and t. Right? That should give me that result. All right. So now we can actually come down and say, oof, we actually want to plot a mag. So let's move our plot down. We've kind of rethought our data. We've rethought how we're going to write this script, and we've included this magnitude of acceleration, right? So now let's run this and let's see. Ooh, this data looks much cleaner. Much, much nicer, right? So we still need a way for like this, like a method to extract these data points. Let's go find these data points. So you could think about some algorithms you could write. Maybe you take the derivative of this thing and you say, oh, when does that equal 0? When does that cross 0? These kind of ideas. Or we could just use MATLAB's built-in approach, which MATLAB pretty much always has a built-in method for data analysis or signal analysis, right? And we're going to use this function called find peaks. I'm going to write it here. Let's say I want to find the peaks of the data. All right, so this function called find peaks takes in some data. We're going to call it just a mag. And then it has a bunch of options after that, and we'll explore that in a second. So let's just run this and see what happens. Ooh, look at this. MATLAB is finding some peaks. All right, it's finding all the peaks. This one. It's finding this local one. It's finding that tiny little peak. All these little peaks that we don't want. It's finding everything that we can ask for, right? Any positive peak. So we have to find a way to filter all that out. So what we're going to do is just go type in help, find peaks, and see what MATLAB says about how to clean up these signals. Right? We can look through all this stuff, or we can go to the documentation. Documentation usually is nicer, has the examples all shown nice and pretty. So let's look at this. So here's some signal that they're finding these peak locations for a bunch of different cases, right? And we want to find a signal that kind of looks like ours, right? We want to find, oh, there's one. That kind of looks like ours. And we want people to do this kind of thing, right? We want to be able to, we already did this, and we want this. Man, MATLAB just basically solved our issue for us in their documentation, right? So how did they do this? Well, they loaded some kind of data that they had. They extracted some data, blah, blah, blah. They went and find peaks, average spot for the year, right? Something like that. And this was just find peaks of year versus, looks like average spots or something. And then, oh, look, they cleaned it up. They have this min peak distance. So what does that mean? Let's look. Use peak locations returned by find peaks to commute the mean interval between maxima. Okay. Well, it doesn't really tell me anything about min peaks. It just uses it, right? Okay, so when that happens in MATLAB, we've got to go down to the documentation they have somewhere else. That's usually all the way at the bottom. So let's see what min peak distance is. Min peak separation is what they call it. So this is a positive real scalar. When you specify a value for min peaks, the algorithm chooses the tallest peak in the signal and ignores all the peaks within some minimum peak distance of it. Oh, it sounds exactly like what we want, right? So let's just try to use that. Let's just try to go for it. MATLAB did it in this little tutorial thing. It must work for us, right? Probably. So it looks like we have a bunch of different types of filtering. Min peak prominence is the last one. This is min peak distance. Let's extract that. And we'll just use it right in our find peaks. Just like that. Let's just call this maybe 20. Let's see what happens. Run it. Okay. Well, you know, when last time we had tons of peaks that it was finding over here, and it cleared some peaks. These peaks are gone. That's nice. But it turns out this data, you know, has a ton of data points, and we want to try to find out kind of what's the spacing between this peak to this peak. How many data points do we have, right? So let's just keep increasing this number until we get kind of what we want. Let's double it. Let's see what happens. I doubled it, and we're finding peak from the peaks that we want and the second peak. So that's not so good. Let's do another double. Oh, that looks much better, right? Are we missing any peaks through this analysis? Let's see. No, we pretty much got all of them. That's nice. All right, so 80 is what we wanted, right? So yeah, we can make an algorithm that goes through all the find peaks and tries to make the best periodic data that we can. Or we can do it by eye right now. And because we don't have really that much data, let's just do it by eye, right? Why waste a ton of time making a nice algorithm? All right, so, but we know that we do want to make this a variable in the future. So let's just call it MPD. And then take that, say MPD is equal to 80. So I'd like to find the locations of those peaks. I know it's giving me the plot right here, which is really nice, but why can't MATLAB just tell me where these peaks are? Like, they should just be able to output that as a variable for me, right? Let's see. Let's go back to our documentation real quick. Let's see, they don't have find peaks equal anything. They just have, MATLAB is just giving me plots. Do they have anything where they give me, oh, look at this. They output something from find peaks. This says PK and LC. Let's try to find out what that is. So let's go down here and see what MATLAB, oh, got output arguments. Nice. PKS is the local maxima. So this is a vector of signal values. If there are no local maxima, the peaks are empty. So PKS says what is the value of my Y value of that peak that I just found and put an arrow on. Locks. Oh, peak locations. That's kind of what we wanted, right? peak locations return as a vector. If you specify a location vector x, then lox contains the values of x at the peak indices. Oh, okay. So I think x is going to give me the